All right, welcome back, generals, to another Let's Fix the Generals to Zero, how to make the best game ever. Last video we dropped off taking a look at unassemblize tool from the Omniblade. Yeah, so I think there was a little bit more conversation. So Thompson's copied this thing here. So he says copy this stuff into the config file, yeah. So we open this one, yeah. And then we copy all this junk here. All of this. In here. Do we care about the order? I'll just put it here at the start, I guess. Okay. Okay. Then there's that. And okay, what's next? With config present in same dir unassemblize game dots. Okay, let's try that. Oh, yeah, I think that's it. Okay, let's see what happens. It created a program.s, but that's it. Okay, so he says you need to pass it a start and end address of the function you want to extract as assembler, unless the config contains metadata on what functions are where, which we do. And let's start work on to start considering a range of ASM to pull out all the functions of into a single ASM. The idea being you would work out where your thought object boundaries were within the exe, and then could pull out assemblable chunks equivalent to the object you were trying to build, and could then dump the ASM into decomp.me or assembly it back into an object you could work with an object diff, or just do a diff against. You need to pass a start and end address of the function you want to extract. So we have start and end, start address of a single function to disassemble, ending address, but we have the functions here. Why don't just take these guys? I don't understand. Okay, so disassemble function. So it only does one function at a time. Disassemble. Start. Okay, it would need to be broken down into modules. That's why we can do binary matching on function level. The binary matching of the entire binary is very unlikely. The function and data order. Yeah. Okay. Okay, so what is in here? Okay, not much. Okay, so I think the program doesn't work as advertised because so it does load config file, but it seems to do nothing with it, right? So it loads this config. But it doesn't do anything with it. What does it? Um. Okay, so my suspicion is that maybe he didn't implement this unless the config contains metadata on what functions are there, and he didn't implement this yet. That's my best guess, but he didn't say it. I suspect this is not implemented yet. Yeah. Okay, so this is get symbol starts. So disassembly function. Okay, so right now these are 0, the start and end address. Okay, what does it do? Let me go in here. So I just forward it to this one, start. So here it basically exits if start is 0 and end is 0. Okay, so how about we first check like what it exactly loads here in our config. Here, load config. Let's put a breakpoint here. And let's see if it actually loads the stuff. Yeah. Let's see. So this one reads all the JSON, I guess. Then find config section config. Let's see what that is. That is this one here. Okay. Okay, find a symbol section. That's down here. Okay, that's where all the functions are. Load symbols. Load symbols here. Load external symbols, and that will load all symbols, I guess. Yeah, address size seems to be everything in here. Okay. Good, then yeah, let's let this run through. Okay. And then once this is done, it will load the other stuff as well. The sections, objects. How about we order it to the same way we write it? So here we... Oh, it is. Don't dump. Submit section. Why is this ordered this way, but in code it's different? Huh? Ah, maybe it's the... I suspect that the JSON parser sorts it by alphabet. Yeah, that seems likely. Maybe there's an option to say J. What options are here? Pass. Load config. J. Is structured. So something like sort. Alphabetic, no. Wow, this file is huge. Oh shit. There's no sorting. Okay, well, it doesn't matter. I thought there would be some option to just... Well, let's search for it. JSON sort object order. Sorted alphabetically, yeah. Preserve insertion order. Aha, order JSON. Okay. So it's literally a different type. Okay. Now, well, I don't know, maybe I break something if I do that. Yeah, let's not mess with that. Perhaps it's good that actually... No, this one is not ordered. Well, it is here, address name site. Oh, okay, well, let's ignore that. Good, so let's revert all the changes we did here. If I would have written this, I would have used the unordered JSON to preserve the order we pushed in, I think. Okay, so it's loading everything, that's good. And then basically it's then it will return here empty and nothing. Yeah. Okay. Okay, how about starts and function? Okay, how about if start is 0 and end is 0, and then oh, what just happened? I hope oof. Let's go to Git. I hope that the formatting is all right. Oh boy. The formatting completely changed. Is there a Clang format file in here or not? There is. Oh boy, text editor. C++. Formatting. Run Clang format. Well, the question is, okay, Visual Studio 2022, C Clang format file. Yeah, I'm in there, but I would like to see. I would like to confirm that it picks up this Clang format file, which is in the project. But it doesn't show me here. Ah, there are more options. Okay, that doesn't help. Good. Choose Clang format file. How about that? Formatting, Clang format file. Formatting. Okay, let's see if the formatting file is listed somewhere here. Perhaps what happens if I add this Clang format here? So it's now listed in here. Does that change anything? Which file did we edit? This one. Let's stop this. Let's press save again. Okay, that didn't change anything. When I save a file, the Clang format looks different as to what is in repo code. Is the Clang format file picked up correctly? Okay, let's delete this again here, remove. Yeah, I don't know what's up with the formatting. For comparison, let's launch Thyme, where it definitely works correctly. Let's see if it's... No, there's no Clang format file in here. Maybe it just picks it up passively, right? Maybe not. I don't know. Okay, anyway, let's just focus on the logics then. Okay, so we have a start and end. Both are 0. Then let's move that in here. Else and then we say so we have loaded symbols. Yeah. So we can do for what's in there? Oh. It's a string. Wait, hold on. Load symbols. Ah, there's a symbol map. Okay, let's look at the symbol map. Okay. What is this? What is this? This here? Address. Okay. Then how about we simply, this preserves order here. So you can just iterate it for so using symbol map. I don't know what the naming convention is for this. Let's call it like this. Okay, for const value type pair. Actually, we can use how about we use this structured binding? I think that is auto address symbol, right? Identifier address is undefined. Huh? Why? Is this C++ 17 or not? Oh, it's 14. All right. Okay, well then we can't use that. Okay, then use const this value type pair. Okay, that's the wrong type. Symbol map, please. Okay, and so address equals pair dot first and symbol is pair dot second as a const and then we just go through one by one. If well, I don't need a if. We just do disassemble output. Output. Disassemble function. Okay, so it has a function pointer here. That's not good. FP into syntax, no prefix. Output program.s. Okay. How about we put that code here instead? If we can access the data, get, well, we would need to symbol map. Okay, so how about here? We have get symbol, get nearest symbol. Then we simply put here const. Let's take this thing here and put it up here. We can't, we have to put it down. Let's put it here. Okay, then we do here. I don't know about the naming convention here. How about we just call it symbol map, like that. Okay, symbol map. get symbol map, and then just const. We go in here, create a new function here and here and here. Return symbol map, easy peasy. And then we remove this here. No, symbol map. Okay. And then we then we take our loop thingy here. Let's copy this. Let's remove this again here. Then we go to main. And we put that in here. And down here we put, so this is the original, when it's 0. Then it does this. Otherwise, start address here and that. Then we have executable here. There is symbol map in here. Symbol map. Hold on. We need exe get symbol map. How about we create a new function, dump function to file. So there's this output. So we make this output. Let's call this file name. File name. Well, that's stupid. If this would be null pointer, it would crash here. Yeah, so we can just remove this. And we can actually simplify this as well here. There we go. We can assert file name. It's not null pointer. Okay. And we need to pass the exe as well. This one. Dump function to section name. Text section. Section name. is a... so we need to check if the symbol, in what section it is. Maybe. Okay, I have no idea about what about the section name thingy here. Okay, so we have the exe here. Then let's take the section name as well. By the way, I hate the auto formatting as I type. Shouldn't do that. C++. Where's the formatting here? Code style formatting. Okay, when I paste, do nothing. I don't know why it auto formats as I type stuff that I don't understand. Okay. Here, why did it format? Don't format. Okay. Visual Studio 2022. Do not auto format on typing. C++. I thought I turned it off already with Thyme, but somehow, I mean, here it says when I paste, indent but do not format. But it's still auto formatted as we type and paste it. Okay, what happens if I select this option here? Let's see. Okay, it still does auto format. Okay, so it's not that. What happens if I put this here? Do nothing. It's still auto formats. That's weird. As is, it just ignores these settings here. Yeah, that just doesn't help here. Yeah. Yeah, so it tells me that it does it, but it doesn't tell me how to turn that off. I don't understand. This documentation is garbage. Why does this not work? Somehow the settings don't apply here. I don't know why. Let's see how it is in Thyme. If I type here, comma, comma. So here it's fine. If I do here, comma, comma. Okay, let's do it with a paste again. So, okay, so here it does auto format. So how about here? We go to a function. And we paste. We just paste. Okay, here it doesn't auto format. So what's different between these things? I don't understand. Yeah, here it clearly does not. And here it will auto format as I paste. So something is set up incorrectly. So here we have the same options. Yeah. I don't know, something is wrong with this project regarding to Clang format. I have no idea what it is. I don't know, but it's annoying. Okay, so we have start and we have end. And then we just pass it on here, start and end. And we also need to, let's do if fp is not null pointer, then we move these guys in here, and then we do f close fp, and why is that 2? Okay. Assert, okay. Let's remove the defaults here. Section name. dump function to file. Okay, so here we also need to fix this one symbol, and so symbol dot size value. Why is it called value? Should be called address, no? Hold on, let's go into symbol value. Let's look at where this is being created. Yeah, it's here, address. Okay, let's change the value to address. Rename address. Value should always be lower than requested address. Let's rename it to address. This as well. Okay, so symbol dot address, and the end is symbol dot address plus symbol dot size, right? And then program. Program.s. So we need to assemble a name for this file. How about program.s? We have what is opt-in? Eh? I have no idea where this symbol comes from. Get opt. Okay. Okay, how about we do a const char xe .exe file. Just so we have a proper name, because argv opt-in is not really helpful. What is it called here on the constructor? File name. Okay. Then exe, let's call this exe file name. Yeah. Okay, so he uses file name. Then we can also, then we rename this to file name as well here. File name. Oops. Okay. Okay, so there's the exe file name, and then how about we take this std string file name. Let's call this function file name, and we put a exe file name and then we simply I wonder if it's possible to put a plus here. I don't think so, because it const char. Okay, let's do it like so. Plus dot plus address symbol dot name plus dot s. Is that fair? So basically it will be game dot function name dot s. So is that a fair name? I mean, it can be changed. So it doesn't matter much. Okay, and then we put here, we call now dump function to file. So basically we comment out this stuff, and here we call dump function to file with, so that's the original, with output exe section name. I don't know what to do with this one. Start address and end address. Yeah. So that's a default thing, but if the both are 0, then we just dump all the symbols that we have in our config file. Get symbol map. Good. And then here we say outputs. We also call this function with our function file name .cstr and our executable and section name. Yeah, we just keep it for now. I don't know. And start and end, we put here this. We have already typed here. Yeah, and then we remove this. Yeah, and this maybe works. So this would now write out a whole lot of files. Right? So let's delete the program.s. Yeah, let's see. So let's put a breakpoint here. And okay, there's some error. Okay. Value Address. Okay. So let's see. So we have address here, yeah, and the symbol. So that's the first. It has a lot of unholy symbols in it. I hope that writes to a file just fine. Actually, I think question mark is not a valid file name. Yeah, question mark. This would probably, let's create a new file here. Yeah, question mark is not allowed. Okay. So okay, so we can't have this and that and this and that and this and that and this and this. Okay. Then C++ strip characters from string there should be a function for this. How to remove certain characters? I think find first off and then remove. Or let's see. Chars to remove. Oh boy. Nice telephone number. Let's look for the most elegant sample here that they have. Whoa, that's a lot here. This one looks nice. Yeah, this one looks nice. It's just weird that like it edits in place, but it also returns a reference to the same thing. That's kind of weird, but okay. We can adjust it. Let's simply put it up here. Remove characters. And we say void std string erase std remove if chars finds std. Yeah, this looks, oops, this looks like a fairly simple algorithm. Remove chars. And then we put here function file name, remove characters. Do we need chance? Yeah, guess. Dot fine. Yeah. And then we simply take this here, this copy, put it in here, this, and we need to escape this character and this character, and that should work. Okay, so this should get rid of all these things. Yeah, let's debug this. How about we just make a pass over this one? Do we have a preprocessor? We have a Windows Win32. Okay, if defined Win32 and then we only remove it for Win32. So let's put a SCD string sanitized symbol name is that, and then sanitize symbol name on Windows, we sanitize it, and then we can use it here. Yeah, okay, I think that's better. Okay, let's run this. Okay, sanitize symbol name. So it should remove the question mark. Okay, let's see if that works. Okay, so the file name is now game.dat.wndproc, and with all this mangled stuff in there, .s. So it opens a file, very good. And then we write this into syntax thingy, and then we have a crash. Great. That is not good. This function may fail. Yeah. Okay, that's interesting. But this was right on the first. Did we pass it some bad offsets? Let's see. Let's run this once more. Fresh. Yeah, let's go in there. Okay, so start is this and end is 5,000. That's quite large. Oh, it's not that large. Yeah, okay. The range looks okay to me. Let's see. Let's step in. Start end. Section name, text. Text, start, end. Start, end, text. And then I guess it crashes here. Oh, what is this? That offset is huge. Start address minus section. But so my understanding is that these addresses are start address minus. So this is probably, yeah. Yeah, I think text section always starts at 400. So if you have 0, hold on, start address. Huh? This offset looks just outrageously huge. Yeah, then here it crashes. Because this offset is huge. I think the problem is that this shows as 0. These section values are not valid, right? Start should not be 0. Program crashes with these. Okay, so we probably would first have to find out why this is 0. Right? It probably shouldn't be. What this causes are these huge offsets, because they are invalid. Yeah. Okay, so we have a blocker there, which we need to get past first. Sections. It already has here some sections. Okay, how about section data? Sections. Okay, how about we do a little bit of improvement here. So we have section, this one. Using a section, oh, I can't type. Section map, this. And return this here. This probably should be const. Yeah. Well, I might as well make this inline then here. It's small enough. Return m symbol map. Then we don't need this in here. Remove this. Okay. Yeah. We need to sort those. Dump sims. Let's see. Let's run this once more. Dump sims. It was debugging. Minus minus dump sims. Game that. Let's make a copy of this. Okay. Then let's put a breakpoint in dump sims. Yeah. Okay, so what section was this? Objects. So this one here. Objects. Hold on. This is just dumping this stuff. Save config. Aha, so it's actually from in here that it's... Okay, let's start again. Symbol map. Where's the object thingy? Where's this being written? Is this target objects? Maybe. Cloud objects. No, that's from the JSONs. Huh? Okay, it's being written here. Let's put a... Okay, target objects. Okay. So what does it do? Find us off. Okay, it inserted something. Game dot sections. Aha, so it does insert 0 here. By the looks of it. Start 0, size. Okay, what is this auto thing here? What is this? Oh, why is it using auto everywhere? What the hell? And of course, when you hover it, it doesn't show you like what it actually is. Ugh. Reference on containers values. Okay, so can we see what's in here? Offsets. What have we... Well, let's put a breakpoint here again. Let's look into IT to see what's in there. Good. So here, IT. Oh, okay, it does have an offset here. Yeah, and I think we need this offset. Yeah. So sections, object sections, start. Yeah. Let's put IT offset here. Yeah. Let's run this. Okay, so now it should have created this one, and now it should have the offsets in there. Yeah, start. Okay, then let's take a copy of this. And then what is a bit weird to me is that this shows as size 0, all these functions here. Well, okay, I guess that's a different issue. Okay, so how about we now delete this one? Now we copy this. Yeah. Then we open it again. And then we copy our new objects in there. Okay, and then we go to then we put game dot again, and we try this again. Okay, so disassemble function. Yeah. Okay. I guess we go in here. Yeah, and now the offset should be valid. No, it's still huge. Okay, let's jump back here once more. Pointer second. But we have an address here, 401. 401. Size. Yeah. So start address. It doesn't make sense. This is smaller and this is huge. So runtime address. I don't know what's going on here. My first instinct would tell me like this. Let's hold on. Let's make a copy of this line and this. That's so weird. But maybe it's correct, but I don't know what the intent here was then. So this minus this. And this minus this, yeah? By the way, we can simplify this section address. What does it return? UN64T, section address equals this. Offset section address minus start address. Okay, let's try this. Let's put a breakpoint here. I have no clue though what the intent here was. Okay, so section address is now this, and this is where the text section starts. Good. And so now this one is that. Okay, that looks valid at least. And end offset is, oh, but that's now less than that end address. Yeah, that's not quite right. Section address. Yeah. My suspicion that all these start addresses were zeroed is that perhaps because we already use that this already uses like a global address, like without any offsets. But I could be I don't know. But then why bother with this here? This I don't understand. So the problem is if we so the section address would be 0 here, start address, but then Okay. Let's put a section address here. Okay, so the section address, offset start address minus the big one. Okay, how about we just zero it here? 0. So then this would obviously be 1000 here, hex. Runtime address. And this one would be 1500, okay. Then the question is plus offset. So this now passes. Okay, let's okay, still crashes. Someone else now. Let's see. It's still on the first. Okay, so where do we go out of bounds then? Aha, here we do another of this. Okay. Then let's do again. Section address. I have no idea what, I mean, this can't be correct if it's crashing, right? Clearly. Okay, let's put this minus 0, minus section address. Okay, let's try this again. Okay, let's see. Okay, that ran through now. Let's see what it produced. Okay, it produced something. I have no clue if this is correct or not. Well, it looks promising. Okay, how about we let this run through all the different functions. Which now generates a whole bunch of files. Yeah. Oh, hell no. Oh, that takes a while. Okay, we have 60,000 files. I mean, I would say let's launch EDR. Some 5. Oh, we got a crash. Okay, so there's still something not quite right. Yeah, this one is over the limit. Offset smaller and offset. Loop through function once to identify all jumps. Offset. I wonder if we just need to change this condition. So right now we are our offset via start address. Section. Okay, but I assume that there's something wrong then. So it assumes that we pass the correct offsets for the right section. And now we went overboard. So there is an address. Here, copy. Okay, let's just scroll down here. How about that? Copy value. Hex. Okay, there we go. Okay, decimal is this. Let's search for this decimal here. Aha. Okay, so starting with this, the address. Section data. Ah. Let's rename this to address offset. Let's take let's do UN 6040 section data. Address offset. Okay, let's close this. Two offsets. What does this return? Okay. Const uint 8t. How about so data is this one here. Data. Can also do the same here. Data. Let's put some question marks here because I have no clue what the original intent here was. Okay, we also need to tell it if our offset is outside this range of the size, then don't do it. So jump table. So let's put a section size. Section size is that. How about we call this section data to be more specific? Section data. There's another section data access. I think this is expensive because it always does a search. Let's optimize this a little bit here. Section data. Executable. Here's another section data. And here's another. Okay. Then it should run a little bit faster. Okay, so I think we need to say if let's go here to the top. So size, start, text. Could be that this should be our offset, address offset. Well, it seems not, because so I suspect this is already a global address. This is not an offset address. Otherwise, like, it would better be named offset. So I suspect we don't need to modify this address at all. So if we keep it address offset, we keep that at 0 for now. I just hope it gives us really the correct offset. I have no clue. Okay, but then we would say here, if end offset is larger equal section size, but this, Yeah, let's scroll down again. So here, so it started crashing here. So this one is basically the next. Yeah. So how about cross text? Section. I think it would be smarter if we don't pass it a M section. If it finds the section automatically on executable, we have do we have something like find section or something? Sections. How about we add a const section info finds section const and then in here we put section info. So find section, we need like a okay, and then yeah. So M sections map. Okay, it's by string. So we need to for section map. Okay, for const section map value type pair in sections, and in there we put if address larger than pair dot second dot, let's put a section info equals const pair second, yeah, info dot address and pair and address smaller info dot address plus info dot size, yeah. and then that returns us this info, return info. Otherwise, let's make it a pointer. Return pointer, and otherwise if it doesn't find it, return null pointer. Yeah, and here also return pointer. Okay, so this should allow us to search for sections. So then we say here, we say, oof, we put this down here, and we put this down. Section data, section size. So here, executable.find section, and we take our offset, yeah, and that should find us now the section info, this one. Let's put that in here. Section info equals this. Let's call this section info, yeah. And then executable, why is this cannot be used? It needs to be const, right. And then we say if section info is null pointer, then return. Instruction, we can move down. In jump table false. Okay, then we don't need this check here. Section size. I think we don't need this check either anymore because, well, we can, yeah. If section info dot size is 0, then also return. Then we can remove this. Okay, and then we have our section data, and we keep that. Let's move this here. Okay. Could this make sense? Runtime address. I have no clue what that is. Okay, so the idea is now, let's run this, that it gets the section itself from the address, right? Oh, return 0. Why? Okay, let's debug this. Okay, find section. Address is that. Okay, what sections do we have? Uh-huh. Okay. Okay, so we need to somehow add this 400,000 here. Hex. Size. How can we address for one? We somehow need to say we need to get this 400,000, but where from? I don't know. Find section. Basically, that. So the shit. So the section data, I think this is correct because if our start address is this 1000 thingy, it's the first function. But in the executable itself, the offset will be at 400, 400,000, 400 and 1000. And that's why That's why here in our sections it also says that it starts here. How do we get this 400,000? So here we added this offset. I wonder which sections. Let's run this here once more. Pref2. Oh, what is this? It's not easy here. Oh, why is it not going in here? What did I do wrong now? It should go in here, no? No? What happened? Ah, we have a header here, no? Header. Aha, here, image base. There we go. Image base. Base of code. Image base. image base. So this binary thingy, let's stop the debugging. This folder is pretty heavy here. Binary. Let's do a const binary pass. Yeah. Okay, let's just return a pointer. Get binary const return mbinary.get, and of course we add some weird symbol here. I don't want this symbol. Tools, options. I think it's a visual assist option. Where is this? Extensions here, visual assist. Here, this one, it's bad option. Format after paste, no. Aha. Okay, so now it should no longer give me a pointer. Good, thank you. So get binary. Let's go to function. Let's go in here, remove the dump sims again. Let's say here find section. mexecutable dot get binary now we just need to find this. Oof. Okay. Const leave binary pointer binary. Okay. Binary. Shit. Exported format functions. Image base. There we go. So, and this returns what? UN64. Okay. UN64T image base. Image base. And then we do image base plus offsets. Okay, this somehow is incomplete. Need binary.hpp. Okay. Okay. So hopefully this now finds it. Let's see. Okay. Let's see. So we have binary, yeah, image base. That's 400,000. And now this should find our section, and it does. Very nice. Section data. Okay, it's valid. And now this should run through. Let's run this. Okay, so basically it now will regenerate all these files. Let's just let it work. Okay, so the hope is that once it reaches those addresses down below, where which is in another section, it just recognizes the section on its own, right? And we got a crash again. Okay, that's not good. Let's see what's wrong. Okay, it's again this one. So what section did it find? 939. Yeah. Section data. Ah. Okay, I think there is like a mixture of things going on here. Yeah, okay, we need to get those addresses right. Oh, okay. So question is, okay, I start to understand why this something is necessary of this sort. Section address. So this one is 1000, yeah? Hex 1000. And so now we went on to this one, I think, right? Yeah, we went on to this one. And so we need to minus. Could it be? Okay, I think here, find section, we need to do image base plus mstart address. Yeah. That will find us the section info. Okay. And then down here, let's move these guys down here. Let's move this down here. So, intro table, runtime address. Okay, so started was 1000. and we will deduct address. How about we make this except section info address minus image base. Yeah. That should give us the offset. Let's put a break here. Okay, so we have here runtime address. Okay, and so offset should now become 0 because, yeah. So here we have this minus this. So this is 1000 and offset should now be 0. And end offset 500, okay. Okay, this could be correct, yeah. Okay, let's see. Okay, that passed. Okay, let's run this through. Let's see what it does. Yeah, let it run. And don't look into the folder with 100,000 files because it puts pressure on the file system again. Let's not do that. 100,000. I will zip this up and send it to Thompson's. Please check if all 100,000 are correct. Thank you. Okay. Can also make this const. Okay, is M section now actually used for anything? Oh, hold on. We got an error here. Let's stop. Section data is wrong. This should be section info data. On that note, let's see if there's anything else here. Aha, here's another section data. Section data. Okay, let's make this const. Runtime address, is this changed? Yeah, it is. But this one is const. Const. Okay, remove this. So if binary is not pointer, or let's just put asserts. It's not 9 point. Oh. Oh, okay, this one is being modified. Okay, then let's run this here. Let's absolutely destroy our SSD. Yeah, it takes its good time. But as long as it's not crashing, it's already a good sign. Yeah. Oh, it succeeded. Look at that. Great. Okay, let's see. Okay, then let's look into some of these files. Oh, it looks really good. Return. Oh, but there's something wrong here. Push. Yeah. I think there should be another push behind this return. Let's see. Let's look at a few more. Why are the function names so shitty? Okay, but this to me looks like a good beginning. There's a return. Yeah. I don't know why there's a knob here at the end. Maybe something is wrong here. Could that be because... Could it be because of this here? To me, it would make more sense if it was like this. Let's see if there are more of these comparisons. here. I could be wrong. Yeah, let's remove these guys. Are there any more of these? Section ends. Sections. Let's change this as well. This as well. Wow, there are a lot of these. Well, I hope I don't break the logic now. Okay, are there such things here as well? I think this should also be in this. Well, I'm not sure. Basically, at the end of this return, there shouldn't be another instruction behind, which to me implies it goes always +1, which could be caused by these comparisons with smaller equal. But if you have an address, like if you have a, let's open your notepad. If you have a address plus size, yeah, then so the end will be not at 1000, but the end will be at 0FFF. That will be the last in hexadecimal, yeah. So you would, if you would check, like if it's invalid range, you check is smaller than H1000 and not smaller equal, because it would already be past this one, right? Maybe that was a bit small, maybe larger. So always compare smaller than this. But yeah, I'm not sure. Maybe I made it wrong. Let's run this once more and see what this now does. Okay, guys, this already looks very promising. We need to wait until this is updated. Okay, we have done quite a lot of changes now to the program. A lot of it is formatting changes, unfortunately. Because something is wrong with the formatter. Or maybe the formatting was not applied previously. That could also be. Yeah. Okay, I think we can also clean up here a little bit. Remove this stuff. Now we don't really need to pass the section name anymore. So for now, I will just say, let's say if this is actually still used somewhere. Unused, remove, to do. Okay, but now this one also shows nothing inside, and this one as well, which makes sense because in here the size is set to 0, so it makes sense that now it doesn't print anything in here. So that's good. So it looks like we fixed that problem. So I expect, yeah, the knob is gone here as well. Good. Okay, so we fixed that bug. Now, I don't know if I overdid it and removed too many comparisons, but they certainly fixed the correct comparison here. So I hope that it just is correct for the other cases as well. Well, someone who reviews it can figure it out. Okay, but this already looks promising. Let's look at a few more. Enumerates. Direct sound. It's a lot of empty ones here. There's a Bing. Bing is also empty. Open. A lot of these are just 1 kilobyte. What's up with that? Okay, but we do have some valid ones. Okay, and the function header and everything, it looks valid here to me. There's some jumps here with a lock. Yeah. Okay. Let's take a look at another. Just RGBA. Yeah. So I think this already looks promising. Then I would say we filter this by name. Then we select all these. Oh boy. 200,000. Okay. 200,000. Okay, 7-zip. Add to debug zip. Oh boy. Okay. That's busy. I do wonder then how we will compare these things here. Perhaps this should be normalized to like a, I don't know, maybe it's already normalized. Could be. Let's look at WinProg. Oh, it's hanging. Okay, we are 3 hours into our recording. I think it's time to take a break, but I would like to send away this by it's dying. It's dying. Okay, let's see if we can clean up anything else. Function unused, remove. Okay. Yeah, this makes sense. Find section. Yeah. Okay, to me it looks like there was simply no Clang format applied before submission. So I think our changes are actually correct here. Yeah. Okay, then that's fine. Okay, so this has finished. No, we are still waiting for the zipping. Oof. Okay, well, I don't know how long this will take. I think I will end the recording session here. I will try to zip this up and send it to Thompson's, and then he can tell us whether or not it's good, usable for what he likes to do. And if not, then make additional tweaks, and I don't know. Try to get this binary matching effort to continue so that we can continue with building Thyme. Yeah. All right. Yeah, I think it was a productive session. We got done what we wanted to do somehow, magically. Yeah, basically we just wanted to dump the function assembly into different files. Now we have 200,000 files, so that's quite a bit large, but yeah, good. yeah, I hope you enjoyed. I will take a break. I wish you a great day or night. Until next time, goodbye.